So hey there fellow YouTubers, it's Frank Bush here again. In today's video I plan on building out a really high efficiency 12 volt DC based stove element. So you'll see in the top left corner of the image that there's a conventional AC powered little stove element that you can pick up at Walmart and those types of places. They're relatively cheap. And that runs off the 110 AC wall power. You know, you just plug it into the grid, if you will. But it consumes about 1,000 watts, which to me is a fairly significant amount of power. You know, it's fairly efficient compared to other things of like mine, but I want to build something that's super efficient that I can use where I'm not having to rely on AC power. I can hook it straight onto a battery and just go off of conventional 12 volt DC power. So in this video today, I plan on taking the different components that you see here in the video on the right hand side of things, if you will. I plan on assembling those into a really high efficiency 12 volt DC based stovetop element. So this should use about 168 watts worth of power rather than the 1,000 that the AC unit is using. And it should be able to produce temperatures of about 220 degrees Celsius. So stay tuned if you're interested in how I kind of put this all together and get it to work. And I'll cut scenes here and we'll start getting it going, yeah? So to give you an idea of why I have these basic things here, these are little like 7-inch pizza trays. You know, picked them up at one of my local wholesale shops for, you know, $2-3 each. Little cooling sheet that's 7-inch as well. I think this one's actually 6-inch. And then I've got a little bamboo lid for steamers and that kind of thing. I took off the handle already, but these are little steamer units you can get, you know, typically for steaming rice and, you know, pot stickers and those types of things, yeah? So fairly simple, common stuff you can pick up just about anywhere. But the reason why I chose to go with these is really this is going to be the main body elements of the stove. So the thinking really will be, this will be the base. I'll have this set down. I'll have this set down on top of it. And then I'll have this set on here. And my heating elements will be attached above. And now I'll switch gears here and show you kind of the individual components I have in this box that are going to be the electrical parts. And like I say, this is really just going to be more of these fit really well together when it comes to sizings and spaces and all that kind of stuff without me having a machine or make much. So they seem to be a really good fit for this project. So this will be kind of the main body that'll just hold the wiring and that type of stuff for the stove, yeah? So like I say, I'll shift angles here with the camera, and then I'll show the electronic components inside here, yeah? So like I say, this project's not overly complicated. So I've got some 14 gauge wire here. This should be able to handle the amperage that I need to push through this unit. And then I've got some heavy wall heat shrink tubing. So this is really, when I solder the different wires together that'll be in this project, I just use some tubing in here that when you apply some heat to it, it shrinks around the wire and just makes it that everything's kind of waterproof and sealed and that kind of stuff. So then I've got a switch, you know, and this switch is designed to handle 20 amps. So like I say, my unit is 168 watts. So that works out to 14 amps or something, somewhere in around there. So needless to say, this should be no problem to be able to handle that. And then I've just got some washers and bolts that'll be used to connect the main housing together. And then I've got little cable ties that are stainless steel. So they're like a zap strap, you know, zip tie, that type of thing. Hopefully the camera's getting that all right. But they're made out of stainless steel. And I decided to go with these because they can handle the high temperatures without, you know, melting any plastics or those types of things. So I'll be using those. And then I've got the little heating element units. So this is them there. And I've got a half dozen of those. And I'll shift camera angles and I'll talk in further detail of these and exactly what they're made of and what they're about, yeah? So like I say, these are going to be the heart of the heating element of my stove, if you will. And as you can see, simple basic little units, 2 wires coming in and out, a little aluminum box, fairly elementary when it comes to wiring them up. But I'll just kind of explain out what these things are and what they do. So these are PTC Thermistors. They are temperature-dependent resistors based on special semiconductor ceramics with a high positive temperature coefficient. That's the PTC, if you will. They exhibit relatively low resistance values at room temperature, but when a current flows through a PTC, the heat generated raises the temperature of the PTC and increases the resistance. So in essence, I'll kind of break that down in a layman's terms for you. So when you apply some electricity to this, you know, these are, like I say, 12 volt DC based, and you can get different varying voltages and those types of things of these units. But in essence, what it is when you apply electricity, these will start to heat up. And when they first start to heat up, they don't have any resistance to the battery, so they'll just soak in the juice as much as they can. And they'll start to get hot really, really fast. So when you wire these bad boys up, they'll start to be hot in like 10, 15 seconds kind of thing. But once these specific units, once they reach 220 degrees Celsius, the resistance steadily increases against the electricity as the temperature increases. So as these get closer and closer to 220 degrees Celsius, they start using less and less power. And then as soon as it kind of reaches that 220 degrees Celsius threshold, the resistance becomes so high that it's barely pulling anything off the battery at all. So really, even though I say this is a 168 watt stove element, the 168 watts being used really peaks right at the beginning. As this thing starts to become hot, the amount of power it consumes drops. So this could easily use 100, 150 watts, you know, that kind of thing, rather than the peak 168 watts, depending on the temperature of the unit. And like I say, these are handy in the regards of they kind of automatically start to decrease the amount of power you're pulling off the battery the hotter they get, which for a stovetop element, in my perspective, is really ideal. It creates a reality where once the stove elements come up to temperature, they really just kind of slow down in how hard they're hitting the batteries. So to me, that's a win-win. It makes it that it's even more efficient. Like I say, together these units, each one of these units is 12 volts DC based, and they use 28 watts worth of power. So in combination, all 6 of them together combined use 168 watts. And that's, like I said, that'll be at peak power. That'll be the maximum amount they draw. Now, when I compare that to the electric stove element that I showed earlier in the video there, that thing uses 1,000 watts. So it already uses more than 5 times the electricity. Now, I don't expect this unit that I'm building to produce quite as much heat as that does, but I do expect it to produce enough heat to boil off a couple cups of water equivalent and that kind of thing. So, and I'll show that near the end of the video, where I'll turn on the 1,000 watt heater, we'll put in 2 cups of cold water, we'll see how long it takes to come to a boil, and then we'll do the exact same with my newly created unit here. And then we'll see, for one, if I can even reach a boil with 2 cups of water, which I believe I can. And for 2, how long that takes. And it'll give you guys an idea of kind of how efficient these are. When it comes to these PTC Thermistor units, theoretically, they have 100% efficiency, just so people are aware. You know, the conversion of electricity into heat is really ideally happening within these units. So I don't know if you could find a more efficient way to create heat from electricity than these units. So either way, I'll stop rambling about, you know, how much of a fan I am of these little things, and we'll start to get on with the build, yeah? Okay, so the first order of business I'm going to do is just take one of my pizza pans. I just brought in this little piece of board to give me something to work on. I'm working on my floor, and the main reason why I tend to do that, if you've watched a couple videos of mine, is my glass table really doesn't do well with the camera of being able to see things on it. You know, I want that opaque surface so that things kind of stand off the surface, and I find the glass table really isn't that ideal at that. But, no, side point. So either way, I'll take my first of my little 7-inch pizza trays here, and then I'm going to take that little cooling rack. I'm going to set that down. I'm just going to set that pretty well right in the center. If you watch previous videos of mine, I do a lot of eyeballing, because to me it's all about just kind of, let's get this thing functionally ready than, you know, something that I plan on marketing to the world. But right in that center point, which that looks like it's pretty centered to me, I'm just going to put a little mark so I know where my drill is going to go. And I'm going to end up drilling a hole through there to feed my wires down through and into that main body, if you will, of the unit. the PTC thermistors are going to be sitting up here, and the wire is going to feed down through the center of this unit, down through this hole, and into the main body of the stove itself, yeah? So let me just get my drill wired up and get a nice hole drilled here, and then I'll cut back, yep. So then, like I say, nothing complex. Just drill a little hole in there. Give me enough room to have the wires run through. As you can see, I'll get a little bit of sandpaper and just clean that up. I won't bother throwing that on camera, but I'll just clean this up so there's no sharp edges, yeah? So now for the next step, like I say, I got the hole drilled in and sanded out a bit and stuff, so I'm not gonna cut any wires or hurt myself on the hole at all. But the next step really is these 3 units are all gonna be bracing to themselves as a one solid kind of entity, if you will. So the thinking really is there's a little bit of a bamboo edge here, and then on these plates, that edge is almost the same size. So what I'm going to do is I'm going to drill 4 holes into both of these pans. I'm going to drill 4 holes that are just in from the edge, and I'm going to do that kind of opposite each other, yeah? And then I'll be able to use the bolts to kind of go through this entire unit then and bolt everything together so that it holds on well. And then the next step will be taking the element holder, if you will, that'll sit on the top, and that'll get bolted on to the one that had the drill hole in it. It'll get bolted on kind of as such, where the wires will be able to just feed through this center area here and right through that hole, yeah? So I'll drill a couple holes and then I'll cut back. So now I've drilled my 4 holes. Here, 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 and here. The same kind of thing matches up on this plate. So that'll give me a place for the bolts to push through to lock everything together. Now I've got to do the same thing on the bamboo. I've got to drill through 4 spots where the bolt will feed up through, and that way that one can sit on the bottom. Like I say, the 4 bolt holes here. The bolts will feed up through the holes in the bamboo, and it'll feed into this unit, and hopefully I'll be able to bolt all that together. I'm not going to do that immediately, but that'll be the thinking really, is to bolt all that together so that it's one single kind of solid unit, if you will, yeah? But I will need to still do electrical work inside this box, so I won't bolt it all together to the end, but I needed to get all my holes in place prior to putting all the electrical in place. And that way I could easily turn around and assemble this in the right order as I went, yeah? And so, like I say, the next step will be just making sure that the holes go through the bamboo there. So I'll line that all up so that's on there pretty solid. And this should be a fairly easy process. I just feed through the existing holes, make sure everything's still holding up flush and that kind of thing. I'm through the bamboo now. As you can see, fairly elementary, right? And maybe I'll even set one of these in to kind of brace this one in place. And it looks like it'll have a nice placement onto that edge, so let me see if I can just use this as a kind of quickly just throw a bolt on here to, like I say, this is not the finish. This is really just to kind of keep things in place while I go to drill those other bamboo holes, because that's right on a nice clean edge here. I'm going to want the same on all the sides of the unit, if you will. So let me just grab my piece of wood. 2 seconds. Because the bolt's pushing through a little past. So let's see if I can set that down. Make sure everything's kind of really flush and square, and looks like happiness is going to prevail. Double check everything. Yeah, it seems to be sitting in a good spot. And I know there's going to be carpenters and all sorts of people out there. Dude, you're breaking rules, man. But such is life. I'll do the same kind of thing now here. set that through. Like I said, that seems pretty clean to this edge, so I'm okay with that. And really, I'm not too worried about whether the bamboo frays a little bit or any of that kind of business, because the bolts are really not going to be there to brace to the bamboo itself on the inside. The entire walls will end up being braced and locked down, if you will, by the tension. So either way, it just kind of gives me a place to ensure that I'm lining everything up nicely, and I seem to be. Everything seems pretty kosher in that regard. So I'll just kind of carry on and get my last 2 holes drilled, make sure I'm in good spot on both sides there. Before I go drilling in, there we go. There we go. All right. So it looks like we should be able to set onto that bamboo nicely now. All the holes have been drilled. And like I say, this was all just a temporary to make sure I knew that the holes all had a good place to be. And I know there's all sorts of videos you can go and watch on exactly how to do this the right way, and it takes 10 times longer, but the risk of having a mistake is nothing, and blah blah blah. But the way I like to do things is just kind of ad hoc, if you will. And sometimes mistakes happen, but I try to make that a minimal effect. So either way, I'll just take this all apart now. I've got all my individual components now, and I've got the holes that they need to be set into. So I'll take this all apart, and then we'll start to look at one of the next steps will be, like I say, the one that has the hole in it. We're going to end up wanting to brace, have the ability to brace this piece to this metal with 2 more bolts that'll sit in to both sides, if you will. And that'll really be just to hold this component to the metal pan, if you will, the aluminum pan. So either way, let me cut angles here. I'll get this bolt out and kind of disassemble this unit back off again. And I'll start to look at just putting in the pilot holes for this to make sure that everything's, you know, ready to roll in that regard. And then we'll start to do the assembly of the electronic components, yeah? Okay, so now back to the one that I originally drilled the hole right in the center. That'll be my top piece, if you will. And now I'm just going to take this part, and I'm going to set that down because it'll be the same whether it's flipped over this way. These machine pressed units are pretty mathematically correct, if you will. But I'm just going to put that back to where it'll be in the center. And you can see the holes are right up to the edge. So when I put some washers on there, it'll want to clamp down a little bit on these edges as well. So, but to be safe, I'm also just going to turn around and say, okay, I can see my holes in there. Everything looks lined up pretty solid. I'm pretty happy with that placement. Maybe a millimeter that way. Now I'm just going to pop in a hole here. Of course, it didn't really want to go through. And this is really just an extra brace. There we go. Put that unit back on there. And it's really just to make sure this has a little bit of extra bracing. So, and I'm going to want to go with that hole. So I got one hole here. I'm going to put the other hole there. Let's make sure. In fact, let's just to make sure everything kind of sits well. Let's see if I can do this. Because there's no harm in that. Make sure things don't wander off too far where I screw myself. Now, I want to put that. Seems to be okay. Everything looks like it's lining up all right. Oh. There's a bit of wiggle room, so for the people that are losing their mind right now about, dude, what are you doing? The bolts themselves have a bit of give, so there we go. And the worst case scenario is I turn around and just make that hole a little bit wider and use a washer to cover up my ugly work. It's not perfect, but it's close enough in my world to function without issue. So that's good. At least I've got it to that point. So now the next step will be actually attaching now the PTC Thermistors to this board. Okay, so now when it comes to attaching these little thermistors here, the PTCs, now these pie plans, or pie cooling sheets, or whatever you want to call these things, I'm sure that somebody that's really into that type of stuff already knows the exact name and is like, dude, you're not calling it right. But either way, I just wanted it for the aluminum. But you can see there's a little kind of shallow depression where they sink down. So I want that part facing up because I want there to be a little airspace that sits between the aluminum underneath that it's going to be bracing to. And the reason why is, even though it's aluminum and it's thermally conductive and, you know, there's aluminum pots and everything else out there, when I go to set on these thermistors, the way that they work is they'll emit heat from the top, the sides, and the bottom. And because aluminum is really good at reflecting heat, having that little bit of airspace in there, the heat that would come off the bottom will be reflected off of the bottom pan, if you will, and it'll reflect back up towards the pot. So that's really kind of the thinking. Plus it gives a little bit of distance between these 220 degrees Celsius elements and anything to do with the electrical. You know, you're creating a bit of space, if you will. But that was my thinking, really, was that the reflectivity, the thermal reflectivity of the aluminum, by having that little bit of an air gap in there, any of the heat that was happening on the bottom side that wouldn't touch the pot and wouldn't really get utilized in ideal ways, as much of that heat that's pushing down off of the PTC, I want it to reflect back into the pot. So that's really the thinking behind me just wanting to flip this over and use it with the kind of curved edge facing up, if you will. So now the thinking really is there's 6 little holes here that exist, and for each one of those I want to set a thermistor right in there, and there's little, I'm trying to show this up close, on the thermistors there's little insulative, like high temperature resistant protective sheathing. That's that white stuff there, and I'm gonna feed those through each one of those holes, but I want to push that thermal resistive, you know, sheath. I want to push that into those holes as much as I can, because the thinking really is there's going to be 6 of these that are strung around the outside, and I want to have it that all the wires combine on the underside and then feed through that central hole that exists in the pan. So they'll all kind of, you know, once they've been joined, they'll all feed through, and then this unit will be bolted onto this unit, and there'll be just wires sticking out the bottom, yeah? So that's the thinking of kind of what I'm doing here. Now, I thought about using high temperature silicone caulking and those types of things when it came to this project, but I had concerns about the temperature threshold gets right up close to what the max of those things are. So my thinking really is going to be that I'm going to use these stainless steel zip ties because they can handle up to 300 degrees Celsius. Now, it's not perfectly ideal. Just bend one and set in place. It's not perfectly ideal because I'm going to end up, in essence, zap strapping these things down to this plate as such, where I'll just wrap this over. It'll feed on through, or kind of 90-degree bend things, and then on the back side, it's just going to be zap strapped in place through the hole here. But I'll turn around, because I know it's not the most elegant on the camera. I'll turn around and zap strap this down, and really what I'm going to take my time, even though I'm not going to show that on film, because I want nice clean, hopefully the camera is picking this up, I want nice clean 90-degree bends to that zip tie, so that when it holds down that thermistor, I want it to hold it down really, really tightly to the board. Yeah? So let me cut angles here. I'll strap one down and you can see exactly what I'm talking about. Alright, so I got the zap strap kind of wrapped around. It's almost fully in there. Just gonna push on the one side and pull on the other. Like I say, I know it's not the most elegant, but you'll see on the camera now, hopefully the camera's getting this good. You'll see on the camera now, that little steel zap strap is kind of bracing this element down, so this element's not going anywhere. And like I say, I've got the protective edges tucked into that hole where the wires now are just feeding out through the bottom. And I didn't bother showing the detail of me straining with these steel, zip ties, because they're a pain in the butt, really. And but needless to say, you got to crank these on as tight as you possibly can, and then I'll just get in there and snip this off as close as possible. But now I want to do that for the other 5, so I'll kind of show steps of that as I go, but I won't bother showing the full details of zap strapping each one of these on, because it really is an awkward thing to really get as tight as you possibly can. But as you can see, there's no real movement in that regard. It's kind of locked on there, fairly stable. It's got a little bit of wiggle on this side just because of that hole, but that's fairly minor. This isn't going anywhere. But that's the key, really, is you want to secure these little PTC thermistors, heat elements, if you will. You want to really firm those down as securely as possible to the plate, yeah? So I'll walk through kind of doing the next 5 of these, the exact same thing, where I'm going to come along and say, okay, this one's going to go in through that hole, and it's going to set down as such. And then I'll put through the 2 little holes here my steel zip tie and strap that one down, and I'll walk all the way around. But in reality, I'm going to turn around and do them opposite to each other to make sure that everything's kind of mirrored up and as even as possible. So it'll be that kind of thing. And then I'll kind of just walk through strapping each one down and kind of put in little cutscenes of each of that so you guys can see it as it just progresses. And then the thinking really is we'll have to bundle these wires up as the next step after that, but I'll show that when we get there. Let me snip off this bit and start to get some of these PTCs hooked on to this plate, yeah? So I guess I should show one of these fully going on so people don't ask questions. But needless to say, kind of figure out where the opposite side is. Now I'm going to want to feed in my zap strap. I just bent it so it's got a nice sharp angle. I'm trying to keep the angles as sharp as I can in that regard, but I want to feed that through that way. And if I was clever about things, I'd turn around and say, you know what? Let's put another bend in there. Let me grab my pliers. Put another bend in this to kind of get myself as clean as I possibly can, using the square of the pliers, if you will. Hopefully the camera's picking that up. Like I say, this is why it's the awkward bit, if you will, but I'm going to feed that up through. Gonna set that on. Yeah, that's all right. Set through pretty flat, kind of like that. Like I say, one of the key things is really got to make sure that protective wiring is tucked in and not going anywhere in that regard. Now this end I'm going to feed down through that hole. There we go. And that came on all pretty smoothly. And now on this side, flip it over. Now I just got to feed it through that zap strap. Like I say, I'm kind of pushing on the other side with my finger to keep everything as close to that PTC as I possibly can. There we go. Gonna feed that through and through and through and through. And this is why I didn't bother showing it on film, because it's not the most elegant filming, if you will. But these zip ties just kind of, like I say, lock down like a normal zip tie. Let's see. Yeah, the metal on that side looks pretty close to the PTC. Let me see on the camera. Hopefully that's giving that justice. So you want to get the zip tie as flat and flush to the top of that PTC as you possibly can. So now on this side, to make sure everything's kind of locked down, I just grab my multi-tool, kind of pinch onto there. I push in against that side and just pulling it as hard as I can. Hopefully that locked everything in place. Yeah, that one's got a little bit of wiggle room just because of the holes up here, but the actual thermistor seems to be strapped on there pretty solid. So I'll just give it another tug because I tend to be like that. All right, so like I say, I'll go and snip these off to be as close as I can here so there's not just hanging chunks of metal everywhere. And as you can see, the insulative cables are cleanly popping through on both sides. We're going to end up joining these things together and putting some of that the heat shrink tubing onto that and stuff as one of the next steps. But I just wanted to show you that it is important to kind of make sure that anywhere where the wires potentially would be touching the metal, you want to have that protection, yeah? And then these will all just feed down through that hole and move away from the heat either way. But like I say, I've got, yeah, this one just seems a bit firmer, but either way, they're not going anywhere. This one, I don't like how it wiggles just because of the size of the holes there. I don't really have a good answer for that, but I know either way, it's not lifting out or going anywhere. So, you know, when I give it a good tug, it's not moving. So it's just got that little bit of wiggle, which I don't like, but such is life. Either way, I'll snip these off, get the other 4 on, yeah? Okay, and you can see I've got 4 of them strapped on here now. This one, like I said, is a little bit, it's not too bad. I just like everything to be perfect. Yeah, it's this one. Because of the hole spacings, has that little bit of wobble, but either way, it's still braced on there. But, you know, you try to make things as perfect as you can. So I'll put on the last 2, and then we'll shift over to the back side of things. But as you can see, all the protective gauge is all feeding down through. You know, it's one of those things where you want to have that all safe and away from the heat as best you can. So I'll hook on the last 2, and then we'll shift over to the wiring side of life, if you will, on this side. Okay, so I've got all 6 of them hooked on now, which is really the core heating element that'll be used now in this stove. So that all seems all right to me. Like I say, all the protective coating seems to be sitting against the metal and that kind of stuff, which is always good. Now on the other side, you'll see there's a bundle of wires here. Now the thinking really is I'm going to turn around and separate one off of each one of those incoming. So in here, there's, like I say, the 6 holes we fed the wires down through. I'm going to take 1 wire from each one of those, and I want to join all those together to form, in essence, if you will, a positive. Then I'm going to take the other wire that came in from each one of the 6 of them, join them all together, and that'll become a negative, yeah? So I'll do that as the next step. Okay, so now for the next part, and take 1 wire from each set, kind of hold them. I'll just pull them out and separate them. Oh, damn. And I just want to make sure that I definitely don't get 2 from the same set. is we want to have them as two separated bundles now. So let me shift that to there. I believe that's going to be our two separate bundles. Just want to double check all of that. So we got one from there, 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 and one from there. Okay, so now what I'm going to do is just use a little piece of tape to keep all of these guys together. So that's going to be one set. And that's going to be the other. I'll grab another little piece of tape just to keep them kind of bundled together. Now the thinking really is, I'll definitely double check everything to make sure, but the thinking really is off of each one of the, let me make sure this is coming in on the camera, okay? So off each one of these two line feeds coming in off each one of these PTCs, I want to have it that one of them is going into one bundle and one is going into the other. And then once I've absolutely made sure that that's happening without question, then I'm going to turn around and solder all the ends together so that I have, in essence, one positive and one negative. And these things aren't polarity sensitive that way, of one way or the other. As long as I get it that I call one group positive and the other group negative, then I'm off to the races. It's really just to give me two sets of feeds, yeah? So I'll just tape this bundle together, make sure that that's kind of held as a group. And like I say, you definitely want to like triple check, if you will, to make sure that you're only taking one off of each one of those PTC thermistors, because if you hook them both up to a positive, it's not going to do anything, right? You have to have that one set of negatives and one set of positives, yeah? So I'll go and double check all that now and just tape up this other bundle, and then we'll look at soldering these lines together, yeah? Okay, so like I say, the next step now is I'm going to take where I've got these two separate bundles. I'm just going to take the one bundle, kind of press it together and twist it into itself. Make sure that's twisted up pretty good. Do the same with the other side. And I really want to make sure that they all have good connection to each other. And then when I'm confident that that's the case, which it appears to be, I'm going to turn around and take my soldering iron. Let me just angle that a bit better. And hopefully I'm getting that on camera okay, but not quite ready to go yet. There we go. Just solder those together. Just do this over this so I don't get little soldered bits on my carpet. I don't mind being generous with this stuff. Like I say, I want to make sure that the connections are good and solid. There's lots of solder on there. Don't want to be shy, because I'll end up joining this up to my main wire that feeds off to the batteries a little bit down the road. So having a little extra solder in the mix is never too bad of a thing. that should be good enough. All right, so I'll just unplug my soldering gun here. Let that sit and cool for a minute. So like I say, we're now at the point where, you know, electrically speaking, we've got a positive and a negative equivalent that'll be on these lines. So then what I want to do is, I've got that heat shrink wrap I showed earlier on in the video, the heavy wall heat shrink. So now that I know that these are kind of, just make sure they're cooled down and everything, it all seems good. So now I'm going to see if I can't stuff these both lines into this heat shrink wrap, keep everything fairly tight together. I might actually have to cut some of this off, so just bear with me. Let's see. Yeah, I don't need quite that much. I'll end up putting more on later on when I go to join on to the main line, the main wires running off to the battery. So this is more just to kind of keep everything tight and bound, if you will. So I'll cut it about there, say. Let's make sure I'm getting that. Yeah, the camera's still sort of seeing things all right. So, such is life. Just put that over there for a second. So like I say, I'll just kind of stuff both of these down through now. Kind of keep everything bound together. Let's see if I can get that to go without issue. The pokey bits are starting to stick through the end. It's always a good sign. And this will be a fairly snug fit because they got a lot of little wires going on here. So needless to say, I'll just get this nested down and on. And then I'm just going to take a lighter and heat this up. And once it's down here, I'll take a lighter and heat that up, and it'll shrink and contract onto the wire and kind of hold everything tight. So let me just jig around with this for a few minutes and make sure that I get this tube all the way down, because like I said, it's a little tighter fit than I thought it would originally be. So let me get that on and make sure that the shrink fit is all kind of in place, and I'll just show you what that looks like. Yeah. Okay, so I've attached on the heat shrink tube, if you will. So as you can see, what ended up happening was that white tape that I put on earlier in the video to kind of bunch these into two sets was just taking up too much diameter, if you will. So needless to say, I kind of slid that over top of both sets of the wires now, and I pushed it up as far as I could here, and then I just applied a little heat. I simply turned around and took a lighter, and still can do a little bit more, so don't mind showing that. Where you definitely don't want to have the lighter on there for too long, but just enough to kind of apply the heat to want to shrink down and contract on that wire. And it really just helps bundle the wires all back up. And then that way when I feed it back through this cylinder, or sorry, a hole that I drilled in this pan, that hopefully it'll be able to feed through nice and cleanly and keep the wire mess to a dull roar, if you will. And then the thinking really is, when I go to attach the main DC wires now, the positive and the negative coming from the battery, it'll go through a little bit of circuitry first, but when I go to hook that on, it'll be, you know, one side will be the positive, the other side will be a negative. I'll put a bit of heat shrink on the connections here after I solder them, so it seals them all up, and that way there's no risk of wires from, you know, both sides, if you will, touching each other and any of that kind of business. But there you have it. It just kind of gives a nice clean bundling of the wires, if you will. That was the heart of what I wanted to achieve at that point. So now the next step will be looking to attach this now to this metal plate. Yeah. Okay, so I'm simply going to take now my element component, if you will. I'm going to just squeeze together that positive and negative so it fits through. In fact, I'll just do this all upside down because it's easier. And I'm just going to feed those wires through. And it's snug, but it fits just nicely. And now you can see that's one of the reasons why I did that kind of wire wrap. It just gives a nice clean feed where the wires will feed out from the metal. And now it's nice and clean on that side. The only thing I really have to do now is turn around and bolt these two components together. So I've got some small 3/16 3/4 bolts, and I've got some washers here. So to try to stay to good practice, I'll put a washer on, just grab a bolt out, and a nut and bolt. Now those holes that I drilled earlier, simply just gonna feed that right through that hole. On the other side, I'll put my washer on. Hopefully I'm getting this all on the camera right. Really simple. I'm gonna brace that down. Now, gotta be careful because I got those wires sticking out the back. Grab a nut and a bolt again. 2 washers. Should be good enough. Now I wanna feed that through. There we go. And the stove is starting to come together. So like I say, I just kind of tighten this on loose enough to have it where it's on there, but I'll just I'll do it off camera because there's no sense you guys watching that, but I'll turn around and just tighten those down. And then the thinking really will be we've got to build out the circuitry that will go inside the main body of the stove that'll connect to this wiring. So we'll start to move into that stage of the builds next, yeah? All right, so like I say, we've got the main element piece, if you will. We've got that all bolted together, so I'm pretty happy with the results of that so far. Fairly clean cut and looks pretty solid in my look of things, if you will. But now I'm going to move on to the concept of, now I want to turn around and have this thing where I can easily flick it on and off without having to attach and detach it from the battery every time I want to use it. So I've got this little switch, like I say, I made comment about it earlier in the video, of pretty elementary. And it's just got 2 connectors on the ends where I can connect on to the wires. And the thinking really is this is just going to sit with a little drill hole coming out the side of this bamboo. I'm just going to have it where this switch sits right on the face here, and it allows me to easily toggle this on and off. So I'm just going to drill a hole in the side and attach this unit onto there, and I'll make that my next step. Okay, so like I say, just ended up drilling a hole now in the side of the bamboo steamer lid and pushed through the switch and bolted it down. A little bit of fraying on the bamboo. I was a little bit careless there, but such is life either way. Still, the switch still works without issue and it's holding on solid and all that happiness, so I'm okay in that regard. But now I'll just connect up that heating element now. We'll have to connect from here to the switch, and then from the switch off to the battery, and the other side will go off to the battery. So it's really simple when it comes to the circuitry that sits inside here of this toggle switch. Is really just that, a simple toggle switch. There's not much more to it. But I'll turn around and clean up some wires and get ready to solder the connection between here and the switch, yeah? Okay, so I've cut a piece of this 14 gauge wire that I had and just exposed an end to it. I'm gonna twist that onto the one of the leads that's coming off of the stove elements, if you will, the PTCs, and just kind of get that ready to be soldered together. And really want to kind of make sure that I'm on there good and solid. I feel like I'm confident with the connection just in how it's bound. And now for the additional touch, we'll put in some solder as well. I definitely wouldn't consider myself a soldering specialist by any means. But either way, I really want to make sure that these connections are done really well and solid. I don't want to be chintzy in that regard. Kind of see if I can reflow them a bit so they're not beating as much. Either way, I'll just put on a good healthy glob of it. No sense in being shy. And that should be good in that regard. Like I said, I definitely don't consider myself to be a solder specialist. My hands are too shaky for that kind of thing. But then, that seems to be a good substantial amount on there. So now I'm going to slide some more of that heat shrink wrap stuff. Put that right over top of the entire bundle of it, if you will. And now I'll just take a lighter to that and shrink it on there a bit. It's hard to do this and keep it in the camera, and in fact I'll just shift my camera to here, tilt that back a bit. That's a bit better. Try to, like I say, you don't want the flame touching stuff for too long for sure, but the tube just kind of shrinks with the heat of it, right? And it'll seal up on those wires and just make sure everything's kind of isolated off from each other. And this is really a super thick walled shrink tube, so it takes a little longer than a lot of shrink tubes would. But either way, we're to the point now where we're wired in now with that larger gauge wire to the one terminal, and the other terminal will do a similar connection off, but that'll feed off straight off to the battery. This connection here now will feed off. I'm going to put a little connect on it so that if I need to disassemble this unit at any point in time, I'm going to put like a little spade terminal onto this end and use that to connect onto the switch. The switch has little screws onto it here, so I'm going to spade terminal onto these, and that way if I want to detach this thing later on in time, all I have to do is undo this screw and I can pop the element apart from the main body of things. I want to have it that if I need to repair any of the components in this in any way, that it's easy enough to do. So that's the thinking really, of I just needed to have this extra line on here so that when this was sitting into the casing body, if you will, as this all comes together, the wire's just going to be able to connect off without issue. Yeah, so one way or the other, I'm at the point where I'll have to dig through my bag and find a spade connector to kind of finish off this end of the wire. So that'll be my next step. Okay, so like I say, for the other end, I'm just going to turn around and put my wire strippers on there, clean off a bit of wire, give it a little twist, and I've got little number 10 spade connector. So if you watch previous videos of mine, I end up using these things all the time, reluctantly. I'm not the biggest fan of them, but they're commonly available, cheap, and easily at my availability. So either way, I'll just kind of set that on, put in the number 10 or the yellow crimp, crimp that on. There we go. Okay, so that seems to be connected really well. So the thinking really is, let me just get rid of that piece. This wire is now going to just be able to connect right onto my switch. Try to Trying to get this on a half decent angle. But it'll connect onto my switch as such. I'm not going to screw it down right at this second, but just to show you, simply screwdriver that down, and then that wire's connected. Then really, I'm going to need to have a wire that comes off this side now, that feeds off to the battery, and it's going to run with a connection that's connected to here that goes through and feeds off the battery. So I'm going to end up needing another little hole here to punch some more wire through to that will be the battery feed, if you will. So I'm going to stop and drill a little hole in the side of here and prepare for the wires to exit the unit. Yeah. All right, so drilled my hole here on the side of the bamboo steam lid, and I'm going to take that 14 gauge wire that I had. I'm just going to feed that through. It's a tight fit, but I'm just going to feed that through, so I've got some lines feeding to the inside now of the container, and I'm going to start to wire up the finishing wiring, if you will, so that this thing will be ready to hook onto a battery. So I'll shift camera angles here, and I'll start to kind of wrap this up for the wiring. All right, so I've got one more spade connector, which I'll end up using. I'll just set that to the side. Now that wire that I just fed in, and I kind of want to split that a bit, because really I don't need quite that much wire, because one side's going to connect off to here and the other side's going to connect off to the wiring that's coming off the elements. So I'm just going to snip a bit of this wire off, just so that things are not too wire inundated, if you will. And now I'm just going to use my stripper to strip off a little chunk and attach on the spade terminal. Just crimp that on. Yeah, so that's crimped on there really solid. Now I'm just going to turn around and, like you said, it's not going anywhere. Hook that on. Grab my screwdriver. And I'm just going to tighten down that screw. It's on there good and solid now. That's not going anywhere. And for the other side, I'm gonna need to strip back a bit of the wiring on there as well, or the plastic sheath, if you will. I'll even give that a little bit more, just to make sure that I can freely have this wire sit inside the body without it being too tight. I want to strip off a good chunk of that plastic. Now this side, just like I did previously, when it comes to this element, I'm just going to pull a bit more of that spare wire through so I got room to work here. So I'm going to do exactly as I did before, where I'll take these two wires and kind of twist them together, if you will. Make sure that they have good connection, so when I put the solder on, that it'll form a good bond. Oh, I almost forgot. Let's take that off. I'm gonna have to put a bit of the shrink wrap sheath on beforehand. So let me just cut a chunk of that off, and we'll say about there. Looks good. Throw that in there. I'll slide this onto the wire first off. That way we know it's on without issue. And turn around, and like I said, I forgot to plug in my soldering iron again. I don't like leaving it unplugged for extended periods of time, so I'll just plug that in, let it warm up. And then now the thinking really is, there was about a 10-foot length of this wire that I did that'll be able to run and go off to the battery. Just so you guys know. So I'm going to take that copper and wrap it around the connections off to the PTCs. Make sure they're kind of good and hooked on there. They seem to be. Good jumbled mess of wire. So I'll shift camera angles. I'll grab my solder, let the soldering gun warm up, and we'll get some solder on there. Then we'll shrink wrap that to seal it all off. We'll connect this piece on, and we'll start to seal this entire unit up, yeah? All right, well, I decided to scrap the heat shrink that was on here and just wrapped it with some tape. The ball of solder I made was just too large to fish on there properly, so such is life. It's not a critical showstopper by any means. So now I'm just going to attach the other terminal to the switch. Hopefully that's being seen on camera, where I just simply have to tighten that down. Now, normally in circuits like this, you would see resistors or fuses and those types of things. But the nature of these units, of the thermal units, they act almost like a fuse themselves. So I'm just kind of pulling back on the cord a bit to start to get ready to set everything in here. But they act really almost like a fuse themselves. Quite often these are used for other applications where once the temperature reaches 220 Celsius and the resistance climbs up, if there was a capacitor, say, hooked on after this, the capacitor would stop charging because the resistance of this would become so high. It's almost like a way to shut things off. So it's almost like a fuse in that regard, but they are also resistors. So you don't really need to have much more complex circuitry when it comes to these systems, because these units really tend to handle all of those types of issues that you would normally deal with in an electronic circuit. So just having a switch on here where it's all wired in and that type of thing is really enough to kind of do the job. Now the thinking really is, all that's going to happen now is we're going to kind of make sure that these wires set flat and that they're all inside the box. And then we're going to start to bolt this box back together. But before I do that, I'm just going to bust out my glue gun, and where I've got the connection on the side for the wires, I'm just going to put a spot of glue gun on the inside and the outside, just to kind of brace that. And potentially I might even turn around and zap strap down these cables just in case it gets tugged really hard. I don't want this cable to come ripping out, if you will. So I'm just going to end up doing that as the next step, yeah? Okay, and just kind of spun it around a bit. So right here, as you can see, I zap strapped down. I just grabbed a zap strap out of my box, zap strapped down the wiring to the bamboo, if you will, and really cranked down on that. And that kind of just locked the cable so it doesn't move too much. If it gets pulled, it doesn't have, it's not just free flowing in that regard. But now I'm just gonna kind of enforce that even further by putting some good old trusty glue gun glue into this zone. Nice healthy glob of it. And now I'll do the same. I'll just spin it around a bit. Do the same on the outside now, where I don't want too much out here because I do want it to kind of still look half decent, but and of course that's not probably going to happen because I get the hands of a gorilla. But such is life. And hopefully that just kind of reinforces that a little bit. It makes it that moisture isn't going to get in as easy and that type of stuff. But either way, a little dab of glue never hurt nothing. So I'll see that now as kind of ready to go. And we'll start to bolt this unit together now, yeah? All right, so let's start to get this thing together. So the thinking really will be, I'm going to need some of these washers. So, in fact, let's just put one of those on. We're going to feed through one of the holes. It's going to feed down through one of those holes. Now, on the bottom side, we're going to turn around and have it where feed through one of the holes, and then we're going to attach on a washer and grab a bolt. Just put a couple of those there for right now. And that'll be the thinking. And now I'll turn around and each one of the 4 that we screwed out earlier in the video, I'll put bolts through each one of these, and I'll come back when this thing's all together, yeah? Okay, well, I went through the unelegant task of threading the eye through the needle, or the needle through the eye, or whatever you want to call that, of these nuts and bolts through the body of the unit. So I'm just going to do a kind of final tightening now. Going across each one of these now and just locking the bolts down nice and tight, right? Make sure everything's really kind of cinched down, nothing's moving anywhere. Come on. Just grab onto that. There we go. There's 2. There's 3. There's 4. All right. This unit's pretty well been assembled. There's one more thing left to do, really. And that's, like I said, I turn around and here, I'll move that out of the way for a second. So there you have it. You've got your stove element that sits on the top here. In essence, that's your burner. And everything's, like I say, it's all locked down and in place. All looks fairly good. You know, for homemade, it is what it is in that regard. But we've got our power switch so we can turn it on and off. And then I've got about 10 foot of cable here that I've attached. Now on this end, I just have to turn around and put on some gator clips probably so I can clip onto a battery. And I'll give the cable a little bit of length. And then I'll probably even put a little bit of heat seal on there so this cable won't run too much. But it does have enough where the battery terminals can be easily reached on larger batteries and that kind of thing, yeah? So that'll be the finishing touches, if you will. I'll grab a little piece of heatsink and just use that as a stopper here. So let's see if I got any kicking around in here. Pull out my trusty pocket knife again. We only need a small amount of that, just enough to be a stopper. So, slide that on. Let's see, where did I go to with the cables? Yeah, about there. Just bust out my liner. Now this will just, like I say, act as a stop. So where the cables are connected together, it'll just stop it from running. Try to keep them as, one cable unit as much as possible, if you will. Just seems to be the best way to go about things. And that'll just stop it from, if it gets pulled here, it won't want to just run and split into two separate wires, right? So now I think in my box I've got some gator clips that I can hook onto here. And so I'll just go and grab those now. We'll grab my strippers. Where did I put my strippers? Here, might as well strip the wire off and get it ready. And if I can't find the gator clips sitting in my box, then I'll just switch up to having like ring terminals or something like that that I can attach onto the batteries so they can be hardwired in, and then you just turn it on and off here, yeah, on the switch. There we go. Excellent. All right, let me fish through my box and see if I can find some gator clips. We'll hook those on and we'll strap this onto a battery and see what kind of performance we're getting out of it. Okay, well, I did find my gator clips, but they weren't the exact ones I thought they were, but either way, I've got gator clips here, but I don't like how it connects on here, and I don't want to hardline these two gator clips. I want to have the option to be able to change it out through time. So my thinking really is I've got these little spade terminals. They should sit nicely in underneath those gator clips underneath the brace there, and that way I can use the best of both worlds. I'll just got to unscrew this, and then I'm down to spade terminals, or I can have the gator clip. So I'm going to do that at this point in time, just to give it a little bit more flexibility. This is really designed to be used more when I'm off-grid camping and those types of things, so I want to have it where if I want to have the gator clips on there and just kind of slap it on when I'm out in the field and off I go, I have the ability to do that. And if I want to kind of make it more permanent and wire it in and rigid it, screw it down and all that kind of stuff, I'll have that option as well. But you'll see the little yellow notch on the crimping tool here. That's the one I want to go with for my yellow connectors, my terminals. Give it a good tug. Yeah, that's on there good and solid. Do the same with the other one. And like I say, this is kind of a strange setup because there isn't any really dedicated positive and negative like you'd have in normal DC stuff. It'll kind of work either way, given the nature of those thermal elements there, the PTCs. But just want to get this in place. Crimp that down. I just always like to really crank those on. And that seems on there pretty solid. So now the thinking really is on these gator clips now, I should be able to, hopefully, without having to unscrew it, get in underneath that washer. And I can just kind of set it down, grab my screwdriver. Either way, as long as it makes good connection, I'm happy. There we go. Like I say, now I can just toggle between the two if I want to, right? I don't feel like I'm being stuck to one side or the other and that kind of thing. And I'll do the same with the other. Let's see if I can do the same trick so we don't have to turn around and unscrew things. And these gator clips are designed to handle 25 amps, and the max that this should be thrown is about 15, so we should be well within our limits in that regard. But you definitely want to always check all the stuff you're putting together, right, to make sure it can handle the amperage that you're wanting to apply. There we go. Seems on there pretty good. Pretty good. All right. Let's hook this thing up and see if we can get something going. Okay, guys. Well, I stopped and did one modification to this, and I didn't catch the filming of that well, so it probably won't be edited into this video, but there's a 1/8 inch board here that I've just I've used some black silicone and some fiberglass cloth, and I just attached it to that board. What I found was I turned this thing on, you know, off camera, if you will. I turned this thing on, and I found the volume of heat that was transferring through the aluminum body of the stove was just way too high, and I knew it was just losing too much heat through there. So I tried to minimize that by attaching this. I might even have to turn around and do a redesign of this top section, but that'll be for a future video. Like I say, this is kind of first prototype, if you will. But this is really just to help insulate the heat so it doesn't transfer to the aluminum and through the frame as easily. I'm going to see, hopefully that helps kind of alleviate some of that heat loss. But after like 3 or 4 minutes of having this thing turned on, the actual body outside of the stove top itself, the body was just getting so hot that if you touched it, you know, you'd feel like it was burning your finger. And if I dropped some water on it, it would just sizzle and go away. So I knew I was losing a substantial amount of heat that way. But either way, I've got these titanium pans here. So what I'll do is, my first experiment is I'll just fill this up with a cup of water, and I'll take ice cold out of the fridge. So it'll be about 5-6 degrees Celsius. I think that's somewhere around 40 degrees Fahrenheit. I can't remember the conversion offhand. And we'll time it and see how fast it can bring that up to a boil using this, yeah? Okay, so like I say, I just went to the fridge and got exactly 1 cup or 236 milliliters of ice cold water out of water I had in the fridge. So hopefully this container is able to hold that all. Should be. And then I'll just turn my stove on. Like I say, just a little on off switch on the side there. Just put that to the side. And I'll just give this a second to kind of come up to temperature. And I'm literally just hooked right onto here. I'll show you. I've got the gator clips, just go up and hook right onto the DC on the battery. And I've hooked to the positive and negative. The wires could be either way in this setup. This really isn't polarity specific, if you will, in that regard. But I can already feel those elements are starting to get hot to the touch now. So one way or the other, I'll just set this on. And like I say, there's exactly 1 cup of water there. And I'll just grab my thermometer gauge and see if I can catch that on camera. That's sitting at, well, temperature's already starting to climb a little, but sitting at 8.3 Celsius. So let me switch that over. Now 48 Fahrenheit. 48 and change Fahrenheit. So, and right now it just turned 11:20. So I'll let this sit now. In fact, I'll just use this as a lid, just because it's always good to have a lid on a pot. And I'll come back when it's at a boil and I'll tell you how long that took, yeah? Okay, so I'm just at the 15-minute mark. It's 11:35 now. So I'll just try not to disturb that too much. Take a temperature reading at this point. So I'm up to 49.4, 50 degrees Celsius, 51, 52. So that's 125 Fahrenheit, 123, 125, somewhere in around there. So that's at the 15-minute mark. And of course there is some hot spots where the elements are sitting in that type of thing. But either way, we're already at 50 degrees Celsius at 15. So I'll put the lid back on. Hopefully we'll be at a boil in less than another 15. We'll see how it goes. Okay, well, we're at the half-hour point now. It's 11:50. So I'll just pop the lid off. Just kind of see a good amount of steam coming off it. We don't appear to be at a full boil yet, but 79.5 degrees Celsius, 80. So 80 degrees Celsius, 173, 175, somewhere in around there Fahrenheit. And like I say, on the hot spots where the elements are, it does jump up a little bit. And I'll show you kind of the bubbling occurring here. It is, well, you got steam on the camera, sorry. But you can see where the elements are kind of heating up the water and that type of thing. It is a little disappointing though. I'm losing way too much heat through. I can barely even touch this metal. Even with that insulation board in there with the fiberglass and stuff, I'm still losing way too much heat through there. I can see that's a fundamental design flaw. I'm probably going to have to do a version 2 of this where I use an insulator rather than a conductor. I just thought the heat reflection would come off of the aluminum fairly well, but it's not performing the way I had hoped it would. So either way, I've got to switch out the conductive surface here for an insulative surface, and I got to research on what'll handle the temperatures that are, you know, up above 200 and that kind of thing without melting and that kind of stuff, right, or burning or whatever. So either way, I'll cut it here at the halfway point, and I'll come back when it does get to a full boil and tell you exactly how long that took. Yeah. Okay, well, we're at the 45-minute mark now, so I'm just going to pop the lid and we'll kind of see where things are at. So just above 90, 197, 198, somewhere around there Fahrenheit. So unfortunately I'm not seeing the performance as soon as I take the lid off. Things look like they might be cooling a little bit. Unfortunately, I didn't hit the vigorous boil that I was hoping for. So I can see that in this design, I'm losing just too much heat through the aluminum, and when I touch it now, yeah, I can barely even touch that, and it's so hot that I can't keep my finger on there for any length of time. There's just too much heat dissipating through the aluminum. So in the next build, I'm going to have to switch up. Potentially I could use this to cook eggs and that kind of thing, and but as you can see, the water's not able to sustain to the point of a boil. That's really unfortunate. There's just far too much heat being lost. So either way, in the next build, I'm going to switch this up to using an insulator rather than a conductor when it comes to the material. I honestly thought that the heat would reflect from the aluminum because I know that aluminum has high thermal reflectivity, but obviously there's just too much contact of the heat to the metal, and too much energy is being lost. So that's really unfortunate. I'll think about my redesign, and it'll be in the next video. But if you enjoy this type of content, please like, share, and subscribe. Thanks for watching, yeah? Cheers.